Yes, students, welcome back. Now we are going to do detailed answer questions from this model paper. And one of the very important questions is prove geometrically that cos of x plus y is equal to cos x cos y minus sin x sin y. Okay, students. Now, since majority of the work is in drawing the diagram, so it has to be drawn carefully. Let me give you some tips on how you can draw this. So let us draw a circle, which is a unit circle. What is unit circle, students? Circle whose radius is 1. All right. Then what do we do? We are going to draw x-axis. Okay, let us represent the x-axis, students. Positive x-axis, and this is the negative part, negative x-axis, x dashed. Let's say this vertical line represent y-axis, positive y-axis, negative y-axis. So the center of the unit circle is at the origin. Okay, students. We say the point is O, which is representing origin. Now we will draw a few points, students. So what I would ideally recommend is from this line, use your protractor, approximately an angle of 110 degrees. How to draw the diagram? I'm just giving you some tips on how you can draw your diagram. So 110 degrees approximately. So you draw a ray here. Okay. Let's say that ray is going to represent one end is O and the other end is P1. Okay, students. Now let us call this angle here, taken in the anti-clockwise direction, as x. Clear, students? Yes? Okay. Now, you're going to draw another ray. Okay, let me call it as OP2. Okay. So what do? From the beginning, from this point. Okay, the total angle, let it be 220 degrees, or in other words, keep the protractor along the line OP1 and once again make an angle 110 degrees. Okay, students. This is just for getting the diagram right. Okay. So that will be somewhere from the beginning, it will be 220 degrees. So that you will be getting a diagram right, because there is marks allotted for your neat diagram. So let this be the point P2. Okay. Now this angle is going to represent angle Y. Clear, students? Okay. Right. Now what you do is from the positive x-axis, which means this line, keep the protractor here and mark 110 degrees in the clockwise direction from here. Clear, students? So you'll keep your protractor like this. I hope it's understood, right? And you'll mark this line. Okay, and you're going to get another ray now. So we're here, right? So this angle you will mark it as minus y, students. Okay, this angle you will mark it as minus y because you are making in the clockwise direction, right? And let's mark this point as P3. And then finally, this ray which is along the x-axis, let's call it as P4, dear students. Okay. Now, we will mark these coordinate students. Now, as you understand, the radius is going to be what? 1 unit, right? So all these radii are going to be 1 unit each. Correct, students? Now this is on the x-axis, therefore this would be 1, but there is no height, so it is 0. Now if you see, when you drop a perpendicular here, right, students? The hypotenuse is 1. This total angle is x. So you can represent the vertical, you mean the ordinate, with sin x. You can represent the corresponding abscissa with cos x. Okay, students? And we know that sin square x plus cos square x is 1, correct? Therefore, I can write this coordinate as cos x, sin x. Clear, students? The x coordinate, the abscissa is going to be cos x. The y coordinate is going to be ordinate, which is sin x. Now, let us look at this, guys. What is this total angle? Total angle is x plus y, correct? So, the ordinates and the abscissa in this case is going to be cos of x plus y. That's the abscissa. And the ordinate is going to be sin of x plus y. All right, students? Okay. Now let's mark point P3. Point P3 is going to be, let me write it here. Because the angle is minus y, it is going to be cos of minus y, sin of minus y. And we have earlier discussed, students, cos function and sin function. If you see, cos function is a even function. So cos of minus theta will be cos theta. So this I can write it as cos y itself. And sin function is an odd function. Therefore, sin of minus y, I can write it as minus sin y. Understood, students? All right. So we have the 4 points now. Now what we do is we construct 2 triangles. All right. So we are going to connect the triangle P1, P3. This is one triangle which is going to be formed. And the other triangle that's going to be formed is going to be the triangle P2, P4 line I'm going to join. Okay, students? So OP2, OP4 is going to be one triangle. P1, OP3 is going to be another triangle. We can very easily prove that. See, you can clearly see OP2, OP4 unit length, correct? Because they represent the radii. Similarly, OP1 and OP3 also represent the radii. So if you see, very easily we can prove according to SAS rule of congruency, the 2 triangles are congruent. So let me write it here. So the triangle P1, O, P3 is congruent to triangle P2, O, P4. This implies that corresponding sides will be equal. So which means the length P1, P3 is going to be equal to the length P2, P4. And distance formula, all of you know, so which is root of x1 minus x2 or x2 minus x1 whole square plus y2 minus y1 whole square. We can use that. Right, students? Now, to avoid the square root, I'm going to square on both sides. So P1, P3 square is going to be equal to the distance P2, P4 square. Clear, students? Now, when I'm doing P1, P3, right? I'm doing P1, P3. Probably I'll take this as x1, y1. Or this is x2, y2. Distance formula is root of, either you can take x1 minus x2 or x2 minus x1. Doesn't matter because you're squaring it. So when I square it, you can see here, I will get cos x minus cos y whole square. Plus sin x minus of minus sin y, which will become plus sin y. Is equal to P2, P4. Now P2, P4, again I can take this as x1, y1. And this is x2, y2. And use the distance formula. I will get cos of x plus y minus 1 whole square plus sin of x plus y minus 0 whole square. Clear, students? Simple distance formula we are using here. Now let's simplify this. A minus b whole square is a square plus b square minus 2ab plus, now let me write the next one, which is sin square x plus sin square y plus 2 sin x sin y. That's what I get on the left hand side. Right hand side, let us see. A minus b whole square, that will be cos square x plus y plus 1 minus 2 cos x plus y plus sin square x plus y. Yes, students? So now let us simplify further. You can see that cos square x plus sin square x. What is that going to be, students? 1. Cos square y plus sin square y. 1. 1 plus 1, 2. Then from these two, I'm going to take 2 outside, minus 2 outside. So what would I get? Cos x cos y. Remember, it is minus sin x sin y. This is a place where students usually go wrong, because here I have a plus. So when I take a minus outside, inside it will become minus, so that minus into minus becomes plus. Correct? Now let's look at this side. Cos square x plus y plus sin square x plus y. Cos square theta plus sin square theta is what? 1. That is 1 plus another 1, which becomes 2 minus 2 cos of x plus y, students. Okay. Now I can bring this term which is negative to this side. This term which is negative here to this side. And 2 on both sides will get cancelled, because 2 minus 2 will become 0. So I get, when I bring minus 2 cos of x plus y, I get cos of 2x 2 cos of x plus y is equal to 2 times of cos x cos y minus sin x sin y. So what gets cancelled, students? This 2 gets cancelled. We get cos of x plus y equals cos x cos y minus sin x sin y. Clear, students? This concludes our proof. It's almost a short question, isn't it? In your quarterly exam, please draw the diagram very clearly as I have explained. All right. Then that does most of your work. Then you of course describe the unit circle and all these points and the angles, but soon you arrive at the congruency of these two triangles, hence the two distances being equal, and then using distance formula, you're getting the proof. Cos x plus y, cos of x plus y is equal to cos x cos y minus sin x sin y. I hope it's clear to you, students. Please practice this derivation twice or thrice so that in the examination, you can get it as a free flow. Okay? All the best. Now let's move on to the other questions which are available in the paper. Let's look at question number 24. Prove that cos 7x plus cos 5x divided by sin 7x plus minus sin 5x is equal to cot x. So here we will use what we call as the transformation formula. Cos x plus cos y is equal to cos of x plus y by 2. In fact, 2 times 2 cos x plus y by 2 into cos x minus y by 2. So for the given question, right, students? Let us write. It is in fact cos 7x plus cos 5x, correct? Which will be equal to 2 cos, see here, in place of x you have 7x, in place of y you have 5x divided by 2 into cos 7x minus 5x divided by 2. So what would this be equal to, students? 2 cos 7x plus 5x is 12x. 12x by 2 is 6x into cos 7x minus 5x is 2x. 2x by 2 is x. So we have cos 7x plus cos 5x as 2 cos 6x into cos x. Okay, students. So we have considered the numerator, correct? Similarly, let us consider the denominator. For that, what is the formula we are going to use? Sin x minus sin y. Again, the transformation formula. What is sin x minus sin y, students? 2 cos x plus y divided by 2 into sin x minus y divided by 2. Clear? So now for the given question, let us write. So it is in fact sin 7x minus sin 5x, correct? This will be nothing but 2 cos 7x plus 5x divided by 2 into sine 7x minus 5x divided by 2, which will be nothing but 2 cos 7x plus 5x, 12x, 12x by 2 is 6x into sine 7x minus 5x, 2x, 2x by 2 is x. Clear, students? So we got what is the denominator. That's all, students. We are almost there. Now let's take up LHS. So what is LHS? LHS is nothing but cos 7x plus cos 5x divided by sin 7x minus sin 5x. We already have got the result for cos 7x plus cos 5x. What is it? 2 cos 6x. Come on. 2 cos 6x into cos x. The whole thing divided by, for sin 7x minus sin 5x, we use what? 2 cos 6x into sin x. So what gets cancelled, students? Just observe. 2 and 2 gets cancelled. Cos 6x and cos 6x get cancelled. You are left with cos x divided by sin x. And we know that sin x by cos x is tan x, and the reciprocal of that is cot x. So cos x by sin x is in fact cot x. And this is exactly what we needed to prove. Very simple question, students, which will fetch you 5 marks. Clear, students? Just usage of transformation formula, which you need to be thorough with. Cos x plus cos x plus cos y, cos x minus cos y, sin x plus sin y, sin x minus sin y. All right, students. Very good. Now we'll move on to the next question. This also we had seen earlier. We'll just revise it once. Okay. Define an identity function. Draw the graph of an identity function. Write down its range and domain. Very simple question. Okay, what is identity function? First, define a definition. A function f from set of real numbers to real numbers that is given by f of x is equal to x. Y is x. Is called identity function. Next is the graph of the identity function. Okay, students. Draw it very neatly. Graph also carries marks. Okay. So let's say this is the x-axis and this is y-axis. The function f of x is equal to x is nothing but y equal to x. We have already discussed it is nothing but a straight line which passes through the origin, right? In fact, it makes an angle 45 degrees with positive x-axis, correct? It is a line y is equal to x, or f of x is equal to x. If you see, the points will be whatever is the value of x, that will be the value of y also. 1, 1, 2, 2, 0.5, 0.5, root 2, root 2. All these are going to be points on this line. Clear, students? Now let's look at domain and range. So what do you mean by domain? Set of all values that x can take, right? In fact, you can clearly see that there is no restriction on the domain of the identity function, which means x can take any value and still y will exist. So x can take any real number. Therefore, the domain of the identity function is going to be a set of all real numbers. Either you can write this like this, or you can write it in words. Set of all or you can also say the domain is x, which belongs to minus infinity to plus infinity. All right. That's going to be the domain of this function. And what is going to be the range, students? Whatever be the value of x, that's what is going to be the value of y. So no problem. So range is also going to be set of all real numbers. Therefore, you can write the range of the identity function is also set of all real numbers. Or you can say y belongs to minus infinity to infinity. Clear, students? Now, this is how you do the question. Very simple scoring question. Okay. So now let's move on to next question, students. Once again, a question from trigonometry. Prove that cos 4x plus cos 3x plus cos 2x divided by sin 4x plus sin 3x plus sin 2x. Clear, children? Okay, now how do you do this sum? Let me explain. Once again, you are going to use the concept of transformation formula. So we know that cos x plus cos y is equal to 2 cos x plus y by 2 into cos x minus y by 2. Now, I will suggest you to do something. Take cos 4x plus cos 2x first. Okay. So let us add. Right. We are adding cos 4x. And the last term, which is cos 2x. Why did I choose the first and the third term? Because they both are even, the angles are even. Therefore, when I divide by 2, I'm going to get an integral number. Otherwise, it will become fraction, right? See what will happen. So this will be 2 times of cos of x plus y. So that is 4x plus 2x divided by 2 into cos of 4x minus 2x divided by 2. Okay, students? So this can be written as 2 cos 4x plus 2x is 6x, 6x by 2 is 3x into cos 4x minus 2x is x, 2x divided by 2 is x. All right, students. Now, next. Similarly, let's do it in the denominator, students. What is sin 4x and sin 2x? First, we'll write the formula for sin x plus sin y. What is sin x plus sin y, students? 2 sin x plus y by 2 into cos x minus y by 2, correct? So, in our problem, what is the value of x and y? In place of x, you have 4x. So, we are doing sine 4x plus sine 2x. So, this is going to be 2 sine 4x plus 2x is 6x by 2. Let me write it in 2 steps. So, we have sine 4x plus 2x divided by 2 multiplied by cos 4x minus 2x divided by 2. Clear, students? So this would be nothing but 2 sine 4x plus 2x is 6x, 6x by 2 is 3x, cos 4x minus 2x is 2x, 2x by 2 is x. All right, now let's do LHS now. So LHS, as I told you, we have 3 terms. I'm going to write these 2 terms first. Cos 4x plus cos 2x. Then I will write this term, which is what? Cos 3x. The whole thing divided by, I will write sine 4x plus the third term sine 2x. Then I will write the middle term, which is sine 3x. Correct. Now what are we going to do? We are going to replace this cos 4x plus cos 2x with what we got here. And similarly, we are going to replace the 2 sin x, sin 3x, cos x in place of sin 4x plus sin 2x, whatever we got here. Clear, students? So let's do that now. So cos 4x plus cos 2x can be written as 2 cos 3x into cos x plus, what do I have left out? Cos 3x divided by sin 4x plus sin 2x is 2 sin 3x into cos x. Correct, students? Plus, what is here? Sin 3x. Clear? Now you can see we are just a step away from our required answer. So tell me, students, from the numerator, what can be taken out? I can take cos 3x outside from both these terms. So what will be left out? Tell me. First term, I'll have 2 cos x. Second term, it will be 1. Correct? Now let's look at the denominator. I can take out sin 3x common. Correct? So when I take out sin 3x common, I get 2 into cos x plus what is left out, students, in the second term? 1. So clearly you can see that I will be able to cancel out 2 cos x plus 1 from numerator and denominator. So what are we left out with? We are left out with cos 3x divided by sin 3x. And what is cos theta by sin theta, students? We know that it is nothing but cos theta by sin theta is cot theta. So cot 3x. And which is what we wanted to prove. Is the whole derivation clear to you, students? Very, very simple. Important type of problem. Just observe what we have done. Do it twice, thrice, so that you're well versed with such questions. Okay, great. Now we move on to the next question. Okay, so let's move on to the 27th question. This also we have discussed in our session. Just a revision for you guys. Define modulus function. Write down its domain and range. All right. Okay. Draw the graph of modulus function. Yes. So define modulus function. Modulus function f of x is equal to mod x is defined as follows. F of x is equal to, whenever x is less than 0, f of x or y is equal to minus x. When x is equal to 0, f of x is 0. When x is greater than 0, f of x is going to be plus x. All right, students, this is the way modulus function is defined, which means whatever may be the value of x, mod x will give the positive numerical value of that number. So what is modulus of minus 2? 2. What is modulus of minus 4? 4. What is modulus of 0.5? 0.5. Modulus of 5? 5. Clear? Okay, let's now draw the diagram. That's the next thing. Graph of modulus function. Let's say this is your y-axis. This is your x-axis. Always remember, students, modulus function is a V-shaped graph. So if you see in the first quadrant and in the third quadrant, the function will exist. Y value will not be negative. Is that clear, students? Okay. So it's a V-shaped graph. So if you see in the first quadrant, the function that will be representing it is y is equal to x, making an angle 45 degrees with x-axis. In the second quadrant, if you see, the function that will be representing mod x is y is equal to minus x, making an angle of 135 degrees with positive x-axis. This angle will be what? 135. This angle will be 45. These are extra information. All right, students. This is the way graph of modulus function looks. This is a function y is equal to mod x. Okay. Now let's talk about the range and domain. See, students, you can see there is absolutely no restriction on the domain of the function. X can take any value, you will get a value for y. Correct? What is x? What is modulus of minus 2? 2. Modulus of minus 100? 100. Modulus of minus 10,000? 10,000. Modulus of minus 1 million? 1 million. Similarly on the positive values as well. Correct? So if you see, the domain is going to be a set of all real numbers. Or you can write x belongs to minus infinity to plus infinity. Right, students? Now let's look at the range of the function. See here, the range is set of all values that y will take. Just check. Y is only positive, correct? Whatever may be the value of x, y is always positive. Therefore, range is only positive real numbers. Is that clear, students? Correct? Including 0. So, what is the symbol representing range? Y. So, y belongs to 0 is included. Yes, the function takes 0 at this point. And it can go up to infinity. Any positive real number it can take. So, the range is going to be set of positive real numbers, or you can say non-negative real numbers. And or another way of writing it is closed interval 0, to open interval infinity. Clear, students? Very simple question. Very easily you can score marks. All right. Let's move on to the last question of this model paper. Okay, now prove that 2 sine square pi by 6 plus cosecant square 7 pi by 6 plus cos square pi by 3 is equal to 3 by 2. See, it's a very, very simple question. Now let us write what are the trigonometric ratios and their angles which are there, right, in this question first. So if you see, we have to deal with sine of pi by 6. Students, already we have discussed pi radians. What is pi radians? What is pi by 2 radians? What is pi by 3 radians? What is pi by 4 radians? What is pi by 6 radians? All these are handy piece of information which you can keep it ready. Correct? So what is pi radians equal to? 180 degrees. What is pi by 2 radians? 90 degrees. Pi by 3 radians? 60 degrees. Pi by 4 radians? 45 degrees. Pi by 6 radians? 30 degrees. Right? So if you say sine pi by 6 is a piece of cake, right? Very simple for you guys, because pi by 6 is nothing but 30 degrees. Sine 30, you know from the table very well, right from 10th standard. It is what? 1 by 2. Clear? Okay. Similarly, if you look at the third part, right? It has cos pi by 3, correct? Squaring we will do later, okay? Right now, we are just looking at what are the angles which are there. So cos pi by 3. And as I have told you, pi by 3 refers to what angle? 60 degree. So it's nothing but cos 60 degrees. And what is cos 60? Once again, from the tables, you know, from 10th standard, it's 1 by 2. Correct, students? All right. Now, one angle where you may have to do a little bit of work is cosecant of 7 pi by 6, right? So we are dealing with an angle which is cosecant of 7 pi by 6. Or if you want to convert it into degrees, if you're comfortable doing that, then I will recommend you to convert that. So then what will it be? It is nothing but 7 into, what is pi by 6, students? 30 degrees. So it's 7 into 30 or 210 degrees. Okay, ma? Now, cosecant 230. See, always when you have an angle like this, of this form, try to write it in the form 90 plus theta, 90 minus theta, or 180 plus theta, 180 minus theta, 270 plus theta, 270 minus theta, 360 plus theta, 370, 360 minus theta. These are called allied angles, okay? Don't worry about the name. So closest is 180 degrees. So I will write it in the form 180 degree plus 30. Okay. Now you have to go back to your ASTC rule. Okay, little work is there here for this question. Once you get the value of cosecant 7 pi by 6, this sum is a piece of cake, right? Okay. Now, we have discussed this also in our previous class. This is 0 degree. This is 90 degrees. This is 180. This is 270. Correct? Now you can see the angle that we are talking about is 210. 210, where does it lie? More than 180, but less than 270. So it is going to be in the third quadrant. And from ASTC rule, we know that third quadrant, only tan and its reciprocal are positive. Cosecant is negative. So the moment you see 180 plus theta, you know that it is in third quadrant. Cosecant will be negative. And I have also told you one more thing. If it is 180 plus or minus theta, or 360 plus or minus theta, you don't have to change the trigonometric ratio. Trigonometric ratio will remain same. So it will remain cosecant itself. If it was 90 plus or minus theta or 270 plus or minus theta, it would change to co-ratio. Cosecant will change to secant. cot will change to tan, sine will change to cos, vice versa, right? So this will be nothing but minus cosecant of the same angle. What is there here? 30 degrees. This is important, guys. What is sine 30? 1 by 2. Cosecant 30 will be 2. So answer is minus 2. That's all. Once you got these three values, it is a simple question, students. Okay, let's do it now. Your LHS is going to be now 2 sine square pi by 6. Or in other words, I can write it as 2 sine pi by 6 the whole square plus 2, sorry, not 2, cosecant square 7 pi by 6. That I can write it as cosecant 7 pi by 6 the whole square. So there is no plus here, so it's a multiplication. Cos square pi by 3, or I can write it as cos pi by 3 the whole square. Clear, students? Now you can see 2 into, what is sine pi by 6? We have already found the value. What is it? 1 by 2. So let us substitute 1 by 2 whole square plus cosecant 7 pi by 6. What is the value we have found? Minus 2. Therefore, it will be minus 2 whole square into cos pi by 3. What is the value we have found? We know that it is 1 by 2. So it's 1 by 2 whole square. So what does this become, students? 1, 2. And this cancels. So you get what? 1 by 2 plus 2 square is minus 2 square is 4. 1 by 2 whole square is also, it's going to be 1 by 4. So 4 and 4 cancels. So what do you get, students? Half plus 1. And what is half plus 1, students? 3 by 2, isn't it? Which is nothing but your RHS. Simple. Correct, students? The only area where you had to pay a little focus was cosecant 7 pi by 6. I hope you understood the procedure clearly. Okay. So I wish you all the best, students, for your upcoming quarterly exam. I hope the session of revision was helpful for you. Take care. All the best for your test. See you all. Bye.